Hello, 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 hello. Can you hear? Hello, hello. Hello, hello. Can you hear? Hello, hello. Hello, hello. Hi. Yeah, actually, I have a lot of interesting background. Maybe we can choose one. Mm, hello, hello. Yeah, I think you can hear me. Okay. Also, I have this one, but I don't think this one is allowed. The maybe the YouTube will block me, so I just changed to this one. Mm. Mm. Okay. Today, I remember you don't have school, right? Today, no school day. I you are eating your okay. Then tomorrow you will go school. Yeah, okay, I know. Because of the PSLE oral test, I know. I have already seen the questions. I think it's not very hard. I guess it's not very hard. Your friends say very hard. Why? I don't know because I don't know what is the point you should get or what kind of question you need to answer. Maybe I think it's just like a small conversation and you just reply the teacher. In general, what's the average? Hi, hi, hi. What's average? Where is average? You mean the sample paper two, the average score? Okay, fine, never mind. Just 1 minute. We will start at 6:30. By the way, I think I can start now. Okay, so yeah, today is our knowledge points run through. So actually, we will just show you some basic knowledge points, and I just separate to several parts. You can see. Firstly, we will talk about the calculation part, right? So some basic calculation formula, and this kind of formula you will definitely meet in the AMO and APM OPS. Okay, and sometimes then after that we'll look at the like maybe some of things is new for you, some you have already learned, for example the geometric sequence, yes, this one. And also after the calculation, another very important thing is about the fraction decomposition. Okay, this one, all the competition, I have to say, all the competition, at least they will test the one or two question about that. Can you be louder? Because my PC sounds small. I think. Let me hear my voice. All the competition, I have to say, all the competition. Ah, I think I speak is very loud. Wait a moment. Maybe I can. Wait a moment. Okay, so I think here is louder. It's louder. Okay. So the fraction decomposition, sometimes you need to find out the general term and you need to find out the general case. Then after that, do the split. And after that is about the number theory. The most important part is the divisibility rule. So you should know what is the basic rule and remember some typical things, right? So how to divide by 5, how to divide by 9, how to divide by 101, 1001, like that. And after that, we'll discuss about the prime numbers and prime factorization. This you learn it very young when you are P3, I remember. So, but sometimes we need to use some method to solve that. A lot of hard questions based on here, and also the remainder calculation is quite important. Okay, are you asking the average of the sample paper too or something? Okay, the second one, I think the average is around 40. Yes, but the highest is very high. Oh yeah, there is a tech mistake. I find it. So every time you can just plus 4 and yeah, you can one 4 point question and one 3 point question. Two answers. You write down the correct one, but the system will think you are wrong. Yeah. Okay. So about some remainder features. So this one is same as the divisibility rule. So actually, you can use the divisibility rule to separate them. Okay. And finally, yeah, that's all today's things. And we also have like the geometry, the counting, and some other things. We will run through it in the next week. Yes, next Tuesday is our uh paper two run through, right? Okay, so now let's look at that. Firstly, we'll talk about the formula and tricks. So basically this one, right? So the sum of the square, a plus b square. How to prove that? You can use just the a plus b times a plus b. Then you open a bracket, a times b times a, and b times b. Okay. So another one is the square difference. It's quite easy. So usually your teacher will ask you to use the big square minus the smaller square, how to calculate the shaded area to find out the result. And after that, okay, so this one, 1 square plus 2 square plus 2n square. So this one is like you can find three triangles, right? So we have one, two, two, three, 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 and until n, blah 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 to n. And also this one, I rotate it, n, blah blah blah, n minus one, n minus one, blah blah blah, n minus one, and one. And finally is you write down like that. This is n, blah 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 blah, n minus one, blah 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 blah, n minus one. And maybe it's too small. And then this is three, two, and one. Okay, so you find out these three triangles, then plus them together. Uh, yeah, you will find 1 square plus 2 square plus 2n square equals to 1 over 6 then times n plus 1 times 2n plus 1. Okay, so another one, very important, this one is like the integer part. Okay, so if you listen to teacher Ethan's almost real paper run through, that time, 15th of July. So the last question, what? Question 33. Yes, it's a kind of triangular number. So this is about the whole numbers, how we can do the separate, how we can do a separate. So this one you can see it's just like what? 1 over 3 times this one. Since you can hear, you can see that this is 1 times 2 and 2 times 3 and blah blah times 2 the other things. You can think about this is 1 times 2 times 3 minus 0 times 1 times 2 plus 2 times 3 times 4 minus 1 times 2 times 3, then plus blah 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 until this n times n plus 1 times n plus 2. Then you minus n minus 1 times n plus 1. So after that, you do the cancellation. Okay, you can do the cancellation like that. We can cancel and cancel all the things, and the remaining one is just the 1 over 3 times n plus 1 then times n plus 2. By the way, you can see we have a lot of calculation formulas you need to remember, but actually sometimes you just remember the basic one, I think is enough. And some question you can just prove that. Okay, in the real question you can just prove that what is the general term, okay. So this is about a general calculation formula, and this one I think is you can just remember 1 cube plus 2 cube plus 2n cube equals to 1 plus 2 to n square. Actually in all the real competition and in yes, in all the real competition, I never see a question test about this one. Okay, so in the past 5 years, okay. So also, yeah, let's look at the next one. Okay, so calculation tricks. So it's about if I want to calculate a very long term, right? Very fast. So of course you can use the pairing and the group. Pairing is like, for example, once you see the last one digit is 2 and 8, 3 and 7, and 4 and 6 like that, you can just combine them. Okay, you just combine them for easier calculation. And the next one about grouping, so some question like, for example, 1 plus 2 minus 3 plus 4 plus 5 minus 6 plus 7 plus 8 minus 9 and plus blah 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 plus until 97 plus 98 minus 99 then plus 100. Okay, remember math is a kind of problem. You find out a pattern. So actually in this question, looks very hard. Maybe you want to calculate from left to right and calculate all the things. Yes, you can, but if I extend to maybe 1000 or 2000, can you still use that method? Maybe not, right? Okay, so that means we need to find out a pattern. What is a pattern? It's just like a plus minus plus plus minus plus plus minus. Actually, you should know before this one, it's also a kind of plus sign. Okay, it's also a kind of plus sign. So actually, you can mix these three numbers as a term. Okay, three numbers as a term. So this one is a group. Okay, so as a group, and finally as a group and plus 100. So if we consider one group, right? 1 plus 2 minus 3, this one is 0. 4 plus 5 minus 6, it will be 3. And 7 plus 8 minus 9, it will be 6. And the last one, this one will be 96. Okay. So as you can see, we just need to calculate 0 plus 3 plus 6 plus until 96. This is a kind of arithmetic sequence, okay? You just need to find out the sum of the arithmetic sequence and then think about how many terms do we have. So the first number plus the last number times how many terms do we have, then divide by 2. Finally, don't forget this 100, okay? You can easily get the answer. So also we have another one. Okay, so fixed missing terms. It depends on the question, and also for example, this one is like, if I want to calculate 21 square plus 22 square plus 23 square plus blah 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 plus 100 square. Anyone can tell me any how to calculate this from 21 square to 100 square in a very fast way? Okay. Okay, anyone can tell me any faster way to calculate this one? Okay, nobody reply. So sad. Okay, so this one is what I don't know how to calculate 21 square to 100 square, but we know what we know how to calculate from 1 square to 100 square, right? So you can just separate to 1 square plus 2 square plus blah 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 plus 2 100 square. Then you minus this 1 square plus 2 square plus 2 20 square, right? This will be faster. You can just use the formula to do the calculation. And what else? So sometimes more often things is like, if I give you the 1 square plus 3 square plus 5 square plus blah 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 plus 2 99 square. They are all what? They are all the odd terms, right? They are all odd numbers. So for these odd numbers, you can do what? I know all of them is all numbers. That means we can give them the even term, right? 1 square plus 2 square plus blah 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 plus 2 100 square. And then, but do we really need this kind of even part? Actually, no, right? We just need to minus the extra even part, okay? So this one, we need to minus 2 square plus 4 square plus 6 square plus blah 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 plus 2 100 square. But someone may say, teacher, okay, I still cannot calculate this 2 square, 4 square to 100 square. Don't worry, they are all what? They are all even numbers. So how can I change these even numbers into a consecutive sequence? Yes, you can just think about this one. We can extract 2 square outside the bracket. It will become 1 square plus 2 square plus 3 square plus blah 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 plus 250 square. Then outside, okay, someone will made the mistake. They will just write down times 2. Okay, be careful about that. 2 square actually is 2 times 1 square. So if you separate this one and you extract this 2, it will be 2 square times 1 square. So you need to times 2 square, but not 2. Okay, so someone may make a lot of mistake like that. Okay, so don't worry about that. Be careful about that. Okay, so now let's look at the small practice. Okay, it's a small practice. Actually, I pick all the questions is like what? It's like the real question in the past year papers. So this is the AMO. Used to be IPFWC. So in 2018, you can find, yeah, this one is a very long term, right? It's a very long term. So firstly, once you look at this kind of question, you need to observe the things, observe all the numbers, and to find out what kind of pattern do we have, right? 2019, 2018, 2018, 2017, 2017, 2016. Okay, I know they are just the consecutive numbers, but are they all plus together or minus together? Oh no, you can see this is minus, plus, minus, plus, and continue to minus, plus, and finally minus. Okay, so this minus may influence our calculation, but maybe we can do what? We can make them as a group, right? So we make this one as a group, and this one as a group, and this one as a group, And the last one, lonely guy, just leave here. Okay, so that means the sum, it will be 1/2 times this one, 2018, right? But I can have the common factor. So of course, we need to extract the common factor. It will be, I use this big bracket, 2019 minus 2017 times 2018 plus this one. We also have the common factor, 2017 minus 2015 times 2016, right? And then plus blah 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 until the last one. It will be 5 minus 3 times 4, right? Times 4. And don't forget the last one. Oh, sorry, I think I missed this one. This is like here. Okay, so this is like here, and we plus the last group, which is what? Which is 3 minus 1 times 2. Okay, so after we calculate like that, yeah, hello. After we calculate like that, you can find this one is what? 1/2 times inside the bracket. These are all what? This is 2, this is 2, this is 2, this is 2, right? They are all 2. They are all 2. So it will be 2 times inside the bracket 2018 plus 2016 plus 2014 plus blah 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 plus 2, 4 plus 2. Okay, they are all what? They are all the even numbers. So since they are all even numbers, I think it's quite easy for you to calculate, right? So it will equals to 2018 plus 2016 plus blah blah blah, blah plus 2 2. So then you just use the consecutive numbers. Maybe you can extract the 1 2 outside, and the inside the bracket is 1009 plus 1008 plus blah 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 plus 2 1. And this is the arithmetic sequence, right? It's 2 times the first number plus the last number times how many numbers do we have, then divide by 2. So 2 and 2 cancel. It will be 1009 times 1010. This one you have to calculate. Okay, you have to calculate. You can easily get the answer. It will equals to B. Okay, equals to 1019090. Okay. So this is our the real question, as you can see. So actually, once you firstly look at this question, you may think, okay, this one super long. I don't want to calculate. But be careful. You are certain. Okay, good. I know. Hi. And after that, you need to observe all the sequence, all the numbers inside this formula, right? So you find what is the common things. Okay, what is the same things, and what is how any common factor I can extract. And after that, we just simplify this formula. Okay, then the question will become very easy. Okay, then the question will become very easy. So after that, yeah, let's look at the next part. Okay, so about the multi-digit numbers. Okay, so for these multi-digit numbers, actually, yeah, you will see a lot of question about the addition, right, like that. And of course, we will have some method to do the simplify, right, to use the easier method to calculate. Of course, when you are P1 or P2, your teacher will teach you how to calculate very fast. So based on that, yes, we have some advanced method. Okay, so the firstly, 9 plus 9, 99 plus 999. Of course, you don't want to calculate, right? This one we will just change to 10 plus 100 plus 1000 and plus blah, blah, blah. Then, how many minus 1? Minus 1 plus 1 plus blah, 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 right? Like that. This one easier to calculate. Okay, so how about 3 plus 33 plus 33? Your score is very low. Yes. Okay. So for 9 to 3, we should do what? We just divide by 3, right? So you make sure this one is equation 1. So you just use equation 1, then divide by 3, right? And this one, yeah, it's 9 divided by 9. So you can use the what? 1 divided by 9. Okay. So 1 divided by 9. Yeah, this is about these things. You can do the easier calculation. And another one for the multiplication, yes, of course, once you see the 9, it's the same things. It will be 1 0 blah 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 blah, a lot of 0 and minus 1. times 8. If you want to calculate the answer, you just obey it. Okay, you just obey it. And the next one, yes, this is the same things. You just get this is 9, 9, blah, 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 9. Then, firstly, we can times 3 to change to the formula 1, but we don't need this 3. We just times a over 3. Okay, so you can keep the answer is same. Okay, keep the answer is same. So the next one, yeah, this is advanced things. So the sum of digit of 9 times 8. What's that? Okay, this one, if we have n9, so that means the sum of the digit is just equals to 9 times n. But this is not always correct. Only what happen is correct. Only this number 8 should be smaller or equals to 9, 9, 9, and 9. Yes, we have this kind of conclusion. If this a is bigger, okay, don't use this one. Okay, don't use this one. This question may be a little hard. Okay, so also the 3 times a is the same. It's not the same things, right? So you cannot use this one 9n divided by 3. It's not same. So of course you need to change to 9 9 9, and we have n9, and then you times a over 3. Actually, it's the same thing. Okay, if a can divide by 3, actually you can find out the sum of digits still 9n. Okay, so but why? You may ask, teacher, why we have this kind of conclusion? You can just try, right? I give you several numbers. For example, we want to calculate 99999 times 1 2 3 4 5. If you don't know this result, what you should do? Of course, you need to calculate that, right? You need to calculate that. But how to calculate? Of course, you should firstly write down 1 2 3 4 5, and all the behind is 0 0 0 0 0, right? And after that, you minus 1. You minus this 5 4 3 2 1. You need to minus this term. Okay? Then after that, you can find out this one. The result, it will be 5. This one, 9 minus 4 is 5. And 9 minus 3 is 6. 9 minus 2 is 7. 9 minus 8 is 8. 9 minus 1 is 8, and 5 minus 1 is 4, and 4, 3, 2, 1. And then you can find out very interesting things. Is what? It's this one plus 8 equals to 9. And 2 plus 7 equals to 9. And 3 plus 6 equals to 9. 4 plus 5, 4 plus 5, all equals to 9. So that means we have 9n. Okay? So okay, so yeah, this is the things. This is the whole things. Oh, you cannot see. Sorry about that. Okay, sorry about that. Hey, so this is the why it's just the 9 times n. Okay, so after that is about division. For example, 1 divided by 3, and 3 over then divided by 9 is the same things. You can just times 9 and do the calculation. And also the 9 divided by 7. Okay, so there is another advanced things is about 99999 divided by 7. So it's something over 7. Uh, it's just like 14285 7 and continue. Okay. So it's like repeat decimal. If you look at 1 over 7, 2 over 7, 3 over 7, and then continue. Okay, then continue. Okay, so now let's look at the next part. Usually we use the page problem. Okay, so page problem, I think it's also a P2 topic. Okay, but it's quite easy. Some things you just remember some very important numbers, 189 and something else, and after that you find out a digit. Okay, so remember, so if you look at the page problem, it will be quite easy. It will be quite easy. Okay, then I find a question about the sum of the digit. Maybe you still remember, some of you. uh, what is the sum digit of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah 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 until this 998? Yeah, this is a multi-digit. Can you tell me what is the sum of the digit? Okay, so if you still remember this method, it's like what? You can combine 1 and 998, 2 and 997, 3 and 996, right? 1 and 998, 2 and 997, 3 and 996, 4 and 995, and continue. You just think how many pairs can we have? And you find a pairs, this one is 3 times 9. This one is 3 times 9. This one is 3 times 9, right? And continue. You can easily find out the sum, okay? You can easily find out the sum. You don't need to care about anything else, right? Oh, why this 5 is outside? Okay, 995. Okay. I don't know whether you still remember this question. It's quite interesting. Okay. Hey, so now let's look at the next part about small testing questions. Okay, small questions. Yeah. Okay, so if s equals to 2, 2, 2, 2, 2, a lot of 2, a lot of 2, a lot of 2, right? What is the sum of the last 5 digit of s? Okay, so this one, yes, actually we have two methods. Of course, you can choose two methods, right? This is 1, 2, 2, 2, 3, 2, and 4, 2, and continue to 2017 2, right? Okay, so how to calculate that? Of course, you can list 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, and 2, 2, 2, 2, 2. Because we just focus on the last 5 digits, right? So that means the before things we don't need to care about, right? So we just after that they are all 2, 2, 2, 2, 2 continue. Okay, then you can find out what is the sum. So basically, I give you two ideas. The first idea is a little hard to calculate. So for example, we just have 2 plus 22 plus 222 plus 2222 and plus 22222 times how many 222 do we have? This is 2000. We only have 2017 terms, right? You minus 1, 2, 3, 4. So the remaining is 2013. Then you find out the sum. But I believe me, nobody will calculate that. It will be too hard. So we can use another way because we just focus on what? The digits. So let's think about for the ones digit, how many 2 do we have? We'll have 2 times 2017 equals to 4034. For the tens digit, how many 2 do we have? We have 2 times 2016 equals to what? 4032. And for the thousandth digit, we have 2 times 2015 equals to 4030. And for the 10,000, okay? Maybe I forgot the 100, sorry. This is 100. And for the 1,000 digit, we have 2 times 2014 equals to 4028. And for the 10,000, we will have 2 times 2013 equals to 4026. Okay? So, yeah, you are right, you are right. Come on, you must use the calculator. Believe me, okay? I know you can use the calculator in the PSLE test, but in competition you cannot use. Sorry about that. Okay, so after that you can do what? You just calculate 4034 plus 4032 plus 4030, 4028, and 4026, and then you find out the sum. It will be what? Yeah, this one it will be 4, 5, 3, 5, 3. And before that, we don't need to care. Okay. Yeah, it's correct. Okay, so the sum you just need to calculate this part. Okay. It's not very hard, right? Okay. So this is about a multi-digit question. I just choose one typical one. So after that, yes, let's look at the arithmetic sequence. Yes, but PSLE is more important. If you perform well in the DSA, you don't need to so care about the competition. That's true. Okay, so now the next part, let's look at the arithmetic sequence. So for the arithmetic sequence, I think this 1, 2, 3, 4, 5, 5 part, right? So you don't need to be very careful. I remember this one we teach in P3, right? And the most important things in find the midterm is a little important. This one we should know. The average is actually equals to the sum divided by the terms. And you can find the midterm, the median number is also this one. So usually we can just use the midterm to do a lot of things, okay? So after that, let's see some applications. So about some cases, we will usually use the arithmetic sequence. Firstly is the natural number sum. So the natural number sum, also we call it this as a kind of triangular numbers. So in all the triangular numbers, the most important things is 1 plus 2 plus 3 plus blah 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 plus 263 equals to 2016. Why this one is very important? Because 2016 is a kind of number related to our this year, right? This year is 2025. Of course, maybe you should get the okay, so it will be the uh it will be what? I forgot. Okay, yes, it will be the year number. This year is 2025. It will be 45 square. Okay. And so sometimes you don't need to care about anything. Once you look at the number we want to do the estimate calculation, you just use that. Okay. Remember that. Because we don't have enough time to do that. Okay, another very important thing is sometimes we know 1 plus 2 plus 3 plus 2 and it will be the first number plus the last number times how many numbers do we have divided by 2. This one is very close to n squared over 2. So sometimes we can just use the square number to do the estimate, okay? To do the estimate. Okay, that's all, I think. This is the arithmetic sequence. So basically, the arithmetic sequence, we will not give you a question for you to test, but we usually just give you the. It's a kind of method. It's a kind of tool for you to solve some harder questions. Okay, so now let's look at this typical one. So I think you just read the question, you can easily find out that, right? So we just have the 50 level store and another one is 38 level store. So if we want to combine them, some student may say, okay, teacher, I know this one is just 50 plus 38 equals to 88. Of course not. Come on, this is a kind of triangular number, right? This is a kind of triangular number. So this is like 1 plus 2 plus 3 plus blah 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 plus 250 equals to a number. And another one is 1 plus 2 plus 3 plus blah 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 plus 238 equals to a number, right? So you need to calculate this one step by step. This one is 1 plus 50 times 50 divided by 2. And next one is 1 plus 38 times 38 divided by 2. So the first part is 1275. And the next part is 741. Okay? So if you find out the sum, it will be 2016. Yes. Once you reach here, so if you have already remember this 1 plus 2 plus 3 until 63, you can immediately tell me the answer is 1 plus 2 plus blah blah blah, blah plus 263 equals to 2016. But yes, it's the answer is 63. Yes, you are right. And but if you don't remember that, you will take a long time to determine that. Okay, you will take a long time to determine that. Okay, so another part is a more important things. Usually in the second round of AMO and APM OPS, in the first round they will test about this one. It's about the geometric sequence. Okay, so maybe this one is the new things for you. So, but never mind. It's the most important is the multiple and the difference method. What is so? Firstly, you should know what is geometric sequence. In the arithmetic sequence, is every two consecutive term we have the common difference. But for the geometric sequence, is we have the common multiple. For example, the first one is a1, then the next one is a1 times q. And the next one is a1 times q squared, and continue. Okay, so it will be this is the first one, this is the second one, this is the third one, and until the last one, the nth one, it will be a1 times q to the power of n minus 1. Okay, So this is like that. And after that, if you want to calculate the sum, s equals to the sum of this part. Maybe we cannot find a very easy method to calculate that. But so usually we will use the method is multiple and find out the difference. So on the both side, we can times another q, q times s. So this a1 will just become a1 times q. This a1q will be times plus a1 times q squared and continue. So this one will just become a1 times q to the power of n minus 1. And this part will become a1 times q to the power of n. Okay? So now if we use the equation 1 and the equation 2, we use equation 2 to minus the equation 1. On the left of the equation, it will become q minus 1 times s. On the right of the equation, this will become a1 times q to the power of n minus a1, right? And after that, you can find the sum actually is just the a1 times q to the power of n minus a1, then divide by q minus 1. Usually, we will use a1 times q to the power of n minus 1 over q minus 1 to represent. Okay, so this is how it gets it. And after that, another very important thing is common test is like about the 2. Okay, so 1 plus 2 squared plus 2 cube. This one, the sum is actually 2 to the power of n plus 1 minus 1. Okay, so this is usually test. Okay, so it's quite important. Also, we have some advanced applications. So, for example, the infinite sequence. Yes, the next question you will see that, and also the arithmetic sequence times the geometric sequence. This one, the only method you can use is to use the multiple and the difference to find out the result. Okay, so when you go to a JC, you will learn new things. It's like a Jacobi sequence. Yes, it's like that name. You will find a general term to solve that, but it will it will be a too far away from now. Okay, you still need to learn about more. How many years? You're if you are 12. Okay, I think after 5 years you all learn that. Okay, after 5 years. So yeah, the infinite sequence and Fibonacci geometry. Okay, you can look at this question. So maybe give you 10 seconds to read this question first. Okay, so let's look at this one. Firstly, we should write on this one. And actually, this question is very kind. They tell you it's a kind of Fibonacci sequence. And they also tell you what is the definition of the Fibonacci sequence is the first two terms are both the first one and from the third term onwards. Okay, so it's like the first two questions, the sum equals to the third one. So now we want to find out s equals to 1 over 7 plus 1 over 7 squared plus 2 over 7 cubed plus 3 over 7 to the power 4 plus 5 over 7 to the power 5 plus 8 over 7 to the power 6 and plus 13 over 7 to the power 7 plus blah 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 blah. All right. So this one you can find. Come on the denominator, every time I times 7. And how about what's on the numerator? Numerator is 1, 1, 2, 3, 5, 8, 13. It's a kind of Fibonacci sequence, right? So that means what? That means this is a combination of the Fibonacci and the geometry. So once you look at this, looks like a geometric sequence, you can just times q on the both sides. So this one, what is the common multiple? You can find the common multiple actually is 1 over 7. So that means we can just times 1 over 7 times s. This one, 1 over 7 times 1 over 7, it will be 1 over 7 squared. And this one will become 1 over 7 cubed. And this one will become 2 over 7 to the power 4. And this one will become 3 over 7 to the power 5. And this one will become 5 over 7 to the power 6. And this one will become 8 over 7 to the power of 7 and plus blah blah blah. Wait, you see, this one you can find, yeah, they are not the same things, right? They are not the same things. But in this one, once we prove the sequence, what is the sum? They have the same things. We can do a subtraction. Is it 1 over 6? Why 1 over 6? No. No. Okay, so this one we don't have the common things. So what should I do? Yeah, maybe you have no choice, but you still need to do the subtraction, right? So let's try to do the subtraction. If we find out the difference between these two, it will, on the left, it will be 6 over 7s. And on the right, this one is still 1 over 7. And this one, it will become 0. And this one will become 1 over 7 cubed. And this one will become 1 over 7 to the power 4. And this one will become 2 over 7 to the power 5. And this one will become 3 over 7 to the power 6. And this will become 5 over 7 to the power 7, right? This one like that. This one like that. Hey, what can you find? And continue, okay? Of course, continue. So you can find a very interesting. What is on the numerator again? 1. Let me show you. This is 1, 1, 2, 3, 5, and continue. What is 1, 1, 2, 3, 5? Is this Fibonacci sequence, right? So that means this one, 6 over 7s, actually equals to 1 over 7 plus, but this Fibonacci sequence, I originally is this s, but now it will become 7 to the power 3. I just times 7 squared times s, right? So now I use s to represent all the infinite sequence. So the only thing I need to do is to calculate what is the value of this s. Okay, so it will become, you can times 47 square on the both side. 1 over 47, 49. No, s is not this one. You need to solve this algebra equation. Okay, you need to solve this algebra equation. So this one will just become 42s equals to 49 7 plus this one s. Okay, so s actually equals to 7 over 41. Here is the answer. Okay, here is the answer. So this one is a little difficult because you need to use the correct method and also be very careful about the calculation. Okay, be very careful about the calculation. So because sometimes you will get a lot of mistake, but if you, but this question I think is very very important because in the history, there are 2 consecutive years they test the same question. This is the same question, and also you can find, uh, yes, they just changed the number 7 to 5. Okay, now let's look at the next part about the number table. A number table is very kind. Actually, this is, you just need to know 2 very important things. What is the term? What the value? Okay, the relationship between term and value. And after that, it's just calculation, just calculation. Okay, so usually we'll see 3 kind of number sequence. The first one is about the square number. So for example, it's like the 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So the order is like here. 1, 2, 3, 4, and 5, 6, 7, 8, 9. So you can find the pattern is all the square number is in this column. Okay, in this column. And another one is like the triangular number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and continue, right? So you can find this one. All these number, they are what? They are the triangular numbers. And the next one is the same things. Okay, sometimes it can change. For example, I choose all the odd number, I choose all the even number. It's the same things. Okay, so you can see what is the sum of all the 34-digit numbers pattern. This one is not very hard. This one is a basic, you just find out sum. If you want to try, you can even calculate all the things together, right? You can get the correct answer. This is not very hard. So actually, this one I have a faster method. You can find what is the medium things. Okay, so you can find the average of this one is just what? It's 2026.5. And this one is also the average of the row and column. So the answer, it will be 2026.5 times, in total we have 5 times 6, 13 numbers equals to 60795. That's all. Okay, that's all. So the number sequence usually is very easy. Okay, uh, usually it's very easy. Yeah. Okay, so now let's look at another very important part is about the fraction decomposition. This one I can tell you every competition will test about that. Okay, every competition will test about that, and also the TASMO. And did I put this question? Oh yeah, I put a very interesting question in the real competition, in the real paper. And this one, yeah, you just need to remember a very two very important things. One is if we find out the numerator is the difference and the denominator is the product. Okay, so like the b minus a over a times b. So remember, you can just definitely separate to 1 over b minus 1 over a, like that. Okay. So after that, it's just sometimes you cannot find it in the sequence. Sometimes you cannot, they just give you the result. For example, 2 plus 6 and then plus 12 and continue like that. You need to know how to separate that. Okay. You need to how to separate that. Also, sometimes, yeah, another very important thing is about usually we will not give you so easy question. Okay, so easy question. You need to find out some interesting part. For example, what is the relationship between the numerator and the denominator? Right. So sometimes you can use n to represent all the things, and then find out the general term. Okay, find out the general term. Okay, so you will need this kind of question. Of course, we will not find all the questions, right? This one we have a lot of method. We have a lot of method. So basically, it's just you need to find out what is the pattern. For example, if I have a mm, 1 over 1 square times 2 square plus one something over 2 square times 3 square plus something something, right, like that. So you can just imagine this one is like 1 over n square times n plus 1 square, right? So you can change to here. But if I give you the question is like 1 over 1 square times 2 square plus 2 over 2 square times 3 square plus blah 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 blah. That means you need to change, it will be n over n square times n plus 1 square. But it's not very easy to calculate, I have to tell you. Okay, and it's not very easy to calculate. And after that, there is another change. Sometimes question will be 1 over 1 square times 3 square plus 2 over 3 square times 5 square plus blah, 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 continue. That will be very hard. Okay, that will be very hard. But you still need to use the same method. Use n to represent. And after that, do the decomposition. Okay, do the decomposition. I give you a lot of hint, so I need to delete this one. Okay. In the real computation, you will mean this one. Okay, so now let's have a try for this example. Let's try for this example. 2 square plus 1. over 2 square minus 1, and 4 square plus 1 over 4 square minus 1, and then continue. Okay. So firstly, remember all the question, you need to find out what is the pattern on the numerator and the denominator, right? So on the numerator and denominator, I know this is just like n squared plus 1 over n squared minus 1, right? But how to separate that? Come on. You find out if I tell you, okay, if I ask you, if you want to find out 1 over n squared minus 1, for example, I want to find out 1 over 2 square minus 1 plus 1 over 3 square minus 1 plus 1 over 4 square minus 1. Yes, definitely you should know how to do that. But if I have an n square plus 1 on the numerator, what should I do? Okay, so firstly, you need to separate, right? So I have an n square minus 1 on the numerator, on the denominator. But of course, if you change the things on the numerator, denominator, it's very hard. But if you want to change the number on the numerator, you just open separate to two fraction. It will much easier. So maybe I have an n squared minus 1 on the denominator. I also want an n squared minus 1 on the numerator. But the value is plus 1. So I just give them 1, 2, right? So now I can just change this question to n squared minus 1 over n squared minus 1 plus 2 over n squared minus 1. So this one will be easy. It's just a 1 plus 2 over n squared minus 1. So what can I do for this original things? Yes, I can write down all the things like that. It will become 2, I just write the easier version. 1 plus 2 over 2 square minus 1 plus 1 plus 2 over 4 square minus 1 plus blah, 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 plus 2, 1 plus 2 over 20 square minus 1, right? Okay, so how many 1 do we have? So you see this is 1 times 2, this is 2 times 2, this is 2 times 9, and this is 2 times 10. That means we only have 10 terms, okay? We only have 10 terms. So this one, it will be 10 plus 2 times 1 over 2 square minus 1 plus 1 over 4 square minus 1 plus blah, 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 plus 2, 1 over 20 square minus 1. When I complete all the things, it will stop, okay? So this one you can find it's just 10 plus 2 times 1 over 1 times 3 plus 1 over 3 times 5 plus blah 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 plus 2 1 over 19 times 21. It seems I should put this 2 back, right? It's a little stupid to extract this 2 at first, but never mind, you give this 2 back. It will be 10 plus 1 minus 1 over 3 plus 1 over 3 minus 1 over 5 plus blah 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 plus 2, 1 over 19 minus 1 over 21. Okay, so yeah, after that I think it's quite easy for you. So it will be 11 minus 1 over 21 equals to 10 and 20 over 21. Okay, so did you find calculate this question faster than me? I think some of you can calculate faster than me. Yeah, if you are very familiar with this kind of method. Okay, I think so. Can you find? I think yes. Okay. Okay, so now let's look at the next very important part. Is about the divisibility rule. Okay, so I have to say this divisibility rule and the prime and the factors question, a factor and multiple questions, they are the basic things about the number theory. So someone may say, why teacher, the number theory is very hard. So which part is very hard? You need to tell me, okay? So I can tell you sometimes, firstly, the number theory, we have a lot of conclusions you need to remember. And another thing is very hard to imagine this question use what kind of conclusion. Okay, so once you meet a question, you may confuse, why I need to use this method, why I need to calculate in that way. And once you see the answer, you will say, oh yeah, that's very smart, but I cannot find out that in the real competition. That's the problem. Okay, so I think the advice for you to practice the number theory is to see, to do more questions. Okay, you will see the commonly tested things. If you see a lot of things, you won't see think this number theory question will be very hard. Okay, if once you look at a question, you are very familiar, and you can immediately find out what is the method. Ah, what's up? No, I think it's about 8. Yeah, I reply you. I remember. Oh yeah, my internet. Okay, never mind. My internet just stopped for a while. It's on board. Yeah, that's true. Yeah. Don't forget that I forgot to change. Okay. Yeah, yeah, yeah. Okay, so now let's look at the divisibility rule. So basically, this is the common things. I think you are very familiar, right? And another one is about the divisibility features, right? So the last few n digits is like 2 and 5, 4 and 25, 8 and 125 is same things. And the factor of 10 to the power of n minus 1. So usually 9 and 9. I only see one question test about 37 last week. Last week or some what time? Okay, I only see one question my student asked me is about the what is the divisibility rule of 37. I think it's very hard, but actually that question we don't need to use the divisibility rule of 37. We use another one. Okay, so also the next part, the factor of 10 to the power of n plus 1, so 101, and 7 times 11 times 13 equals to 1001. This is what you need to remember. Okay, so this one, the first things we call it, this is the last digit group. And this one, we need to find out the sum digit group. And then finally, we need to find out the difference group. Okay, so usually we have the order. Once you look at a question, they ask you, I want to find out whether this is the multiple of 9 and 11 and 5. Okay, for example, 9 and 11 and 5. So of course you need to determine 5 first, because this is the easiest. You just look at the last digit, right? Whether it's 0 or 5. 3 times 37. Yes, you are right. Okay, 3 times 37. Yeah. Okay. And also, one after that, you just look at the 9, whether the sum is the multiple of 9. And finally, you use this 11. So what is the difference, right? What is the difference? Okay. So after that, right, after that, you can look at the next part. Okay, so of course we have a lot of applications. So I just show you one. Okay, so this one I think is a typical question. Why? Because you have a lot of method. Okay, because you have a lot of method. So firstly, 7, 8, and 9. What kind of things we should imagine first? The firstly is 8, right? Because 8 times 125 equals to 1000. So that means these A, B, C, three numbers must be the multiple of 8. But it won't help, right? It won't help. So how about the 9? That means A plus B plus C plus this 4 should be the multiple of 9. So maybe A plus B plus C equals to 5, equals to 14, equals to 19. No, not 19, sorry. Equals to 23. Can I continue equals to 32? Of course not, because 3 digit cannot be larger than 27. And what else? I cannot determine anything. And also the last one, 7. Maybe we can use the 3-digit count from here. A, B, C plus 2, then minus 20. It's the multiple of 7. You may stop at this place. Okay, so you may say, teacher, this one, if I use the divisibility rule, I use your method, I cannot find, right? Okay, so what should I do? Anyone? It's 111. Why? Yeah. Okay, so this one, if of course nobody will calculate. Okay, so what should I do? Usually we should know 2020 ABC. That means the smallest one is 2020 000, and the largest one is 2020 999. That means if we have the multiple of 7, 8, and 9, so the number must be from 000 to 999, right? 000 to 999. That means what? That means we can just use 2020 000 to divide by the LCM of 7, 8, and 9, which is 504. Because if it's the multiple of 504, that means it must be the multiple of 7, 8, and 9. Okay? 7, 8, and 9. So we just use this one to divide by 504. Okay, you can make calculate this one about 4007.9, and you use 2020,999 divided by 504. This will be 4009.8. Okay, so from 4007 to point 0.9 to this one, so there must be two numbers, 4008 and 4009. So the two, we have how many integers? We have two. You even don't need to calculate what is the answer. Okay, you just need to find out how many digits, how many integers do we have. So for this one, you can easily find out it's two. Okay, so that's this question. I just want to tell you, sometimes yes, you can use the divisibility rule, but sometimes you need to change the method, or you will just stop here. Okay, you just stop listing here and discuss ABC one by one. It's not a very good method. So if you just change your brain to this one, we can just estimate. It's a better way. Okay, it's a okay. See you. Bye bye. A. So now let's look at another part. Now we still have one, two, just two things. Okay. So now let's look at the prime number and the prime factorizations. This one is super hard, I have to say. Okay. So firstly, the definition of the prime and the constant numbers. Do you know what is the definition? Okay, the number who only have itself, only itself, and one is factors. So we call this one is the prime number. It's the prime number. Okay, and also a special one too. Two is the only even number and also prime number. Focus. Be careful about that. Okay. Why? Why you hate me? Okay. So after that, yes, the last digit of prime numbers, it can only be 1, 3, 7, and 9. Remember, right? So because 5 is the prime number, all the other things is the multiple of 5. And 1, 3, 7, 9, all the others, they are just the odd numbers. So they are all prime. They are not all prime number. You can use this method to determine that. Okay. So the numbers of prime number below 25, it's a quite important thing. Just now I made a question my student asked me is about can you tell me how many numbers n smaller than 100? That means n factorial is the multiple of 1 plus 2 plus blah 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 plus 2n. So how many n do we have? Yeah, you can just determine, maybe we can just use the prime numbers. Okay, so another one. Okay, so maybe I can give you two questions. If you have interesting, you can prove. So the first one, please prove there are infinite prime numbers. Okay. So the second one, if you have interesting, you can prove that there are infinite consecutive composite numbers. Okay, if you prove that, please tell me. Okay. Yeah, please tell me. Okay. So after that, it's about the prime factorization. Okay. So prime factorization is yeah, it's you are very familiar, right? You can use the ladder method to do the prime factorization, and also the prime factorization can help you to find out the well, can help you to find out what is the LCM and what is the HCF. So basically, for this one is a very important thing is uh a kind of question: how many consecutive zero do we have at the end of 300 factorial, for example, right? So this one, yeah, this one you can just use 300 because if I want to find out zero, zero is the multiple of 5 and 2, right? So obviously under this 300 factorial, we have more 2 than 5. Yes, so you just need to let this one divide by 5, 60 divided by 5, 12 divided by 5, and this will be 2, okay? So you can easily find this is the multiple of 5. This is a multiple of 25. This is a multiple of 125, right? Okay, so after that, you just plus this 60 plus 12 plus 2. You can find out it will be 74 zeros, okay? 74 zeros. So let us times, okay, yes. Right, so this is about this one. And another things, A and B, if they are co-prime, this means the HCF, okay, this means HCF of A and B equals to 1. If they are co-prime, yes, that means A and A plus or minus B, also the prime number is 1, okay? This is also, oh, sorry. Okay, so it's also prime, okay? They are also prime. And after that, okay, so usually we'll have a important conclusion is the Euler's distribution method. So we usually use this one to calculate the numbers smaller than this number x and composite coprime with x. Okay, so how many numbers do we have? We use this one. For example, 2016 equals to 2 to the power of 5 times 3 to the power of 2 times 7. So we use 5 2016 equals to 2016 times 1 minus 1 over 2 times 1 minus 1 over 3 times 1 minus 1 over 7. You can just like that to calculate how many numbers they are coprime. This is a very important conclusion. Sometimes you will find it's very useful. Okay, sometimes you will find it's very useful. Okay, so this one I just pick a very easy question. This one is from the this is from which year? This I think is from the almost paper. Yes, it's from the almost paper. So can you tell me what is the coprime numbers? Find the smallest positive integer n such that neither 4n minus 1 nor 4n plus 1 is prime. Okay, so firstly, you should know 4n minus 1 and 4n plus 1, right? They are what? They are just the two consecutive odd numbers. So we just need to find out two consecutive odd numbers. What's that? Must be n with 5 and 7, or maybe 3 and 5, right? It will be related to 5. So maybe you can try 25 and 27 and 33 and 35 and maybe another one, maybe 9 and 1, 49 and 51. You just try, okay? You just try. Okay. Uh, right. So I think the smallest is just the 25 and the 27, right? Or you try the n equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5, and you can find out that. Okay, you can find out that. So this is the solution. Yeah, 21 is not prime, but 23 is prime. 19 is not prime, but 21 is not prime. All right, 19 is also prime. Okay, so that's all things. Okay, so you can try one by one and find out the whole things. Okay. Can I mute you? No, I cannot. Sorry. Okay. Yeah. After that, yeah, let's look at the last part. It's about the remainder calculation. Yeah, remainder calculation very important. So, but for me, I think the remainder problem is just the one things. Yeah, 11 and 13 are prime. So remainder problems is like find out the pattern. Okay, it's the same thing as the pattern. If you find out the pattern, the remainder it will be very easy to calculate. Okay, it will be very easy to calculate. So the whole things about the basic remainder things is you need to try to find out all the remainder patterns. Okay, all the remainder patterns. So this is like um sometimes you will find this question is very hard. It's very hard. But remember, all the questions you can list. Maybe you list from one to two. Maybe you list from one, two, three, four, five, six, seven, eight, and until maybe the most of the time I remember one question list to 20. And you can also find out the answer. Okay, you can also find out the answer. Okay. So now let's look at this remainder part. So the firstly is about the modular equation. So this one I think you are very familiar, right? So we can, if we see A congruent to B more C, that means A has a remainder B when divided by C. A and B has the same remainder 1 divided by 3. Okay. So also we can use the replacement principle. So if A congruent to A more C and B congruent to B more C, so that means we can do the plus or minus, addition and subtraction, multiplication. Yes, it's all the same. Okay, the remainder we can calculate like that. So after that, another very important thing is sometimes you may forget is A. If we plus this, we can plus a lot of multiple C because the remainder will not change. Okay, the remainder will not change. So the last one is about the combination principle. So if M is congruent to N, if we mod B, M is congruent to N if we also mod C. So that means the B and C's LCM equals to A, and also M is congruent to N if we mod A. Okay, so this one is not very useful. It's not very useful. Okay, so but sometimes you may meet it. You may meet this method. Okay. The next part is you may say, "Oh, teacher, this one is this same as our divisibility rule?" Yes, of course. So it's same as the divisibility rule, but why I still put here? Remember the remainder, the divisibility rule. Another method is we can use this method to determine what is the remainder. Okay, what is the remainder? And you use this one, you can easily find out the remainder part. And sometimes you can use the divisibility rule to do a lot of things, like the next part, the equation. Okay, this small question. And for example, yeah, another one is the general questions, a remainder of an expression, the replacement principle, and sometimes the last one digit you just focus on 2 and 5, and the last two-digit problems focus on 4 and 25, and the remainders of exposure opponent. This one is very important. Sometimes you just list the pattern. Okay, you just list the pattern. And also I give you a general table. Like what? So if for all the natural numbers x and n we have, if you find it's to the power 5, sorry, if we divide by 5, the pattern is 4. Divide by 7, the pattern is 6. Divide by 9, the pattern is 6. And divide by 10, the pattern is 4. So usually you can easier find out the things. And also divide by 100, the pattern is 20. Okay, so at most it's 20, I see. Usually you can find out the pattern. So if you cannot easily find out the pattern, try your best to list more. Okay, try your best to list more. You times the remainder, times the remainder, times the remainder, like that. Repeat. Okay, so now the last one. Yeah, also these two things, uh you can focus on the sample paper 1. It's not a very very important things for you to remember. If you just want to get a gold, or you want to pass the AMO or EPM OPS the first round, you want to enter the second round, this one I don't think it's a very important conclusion you need to remember. But if you want to get a good result in second round, or maybe the top 5 or top 3, Yes, my suggestion is to remember that the Feynman this theorem. Okay, it's quite important and it's quite useful. Okay, so the last one I think is very easy. 1 times 3 times 5 times 7 times 2, 2025. Right? What is the last three digits? The last three digits, that means it's divide by 1000. You can separate to divide by 8 and divide by what? Divide by 125. So firstly, this one, of course, we have a lot of remainder 5. Why? Why is Tuesday? I don't forget, I don't see that. Okay, so divide by 125. That means this one must be the multiple of 125. So it must be remainder 0. So we only need to think about divide by 8. What is the remainder? Okay, divide by 8. What is the remainder? So now we have remainder 1, 3, 5, 7. So you can find it's like uh 1 divided by 8 is remainder 1 times remainder 3 times remainder 5 times remainder 7. Then it's remainder 1 times remainder what? It's still remainder 3 times remainder 5 times remainder 7. 9, 11, 13, and 15, and continue. So we have a lot of groups, and the last one is remainder 1 times remainder 3, and you just need to check 2025 divided by 8. What is the remainder? Okay, what is the remainder? It's same as 25 divided by 8, which is remainder 1. So that means the last one is just continue to remainder 1. So this one, remainder 1, 3, 5, 7, it will be 15 times 7 equals to what? 15 times 7 is 75. 75 divided by 8. It will be remainder what? Remainder 3. Okay, so this is remainder 3, remainder 3, and then continue to the last one, remainder 1. So we just need to care about how many group of remainder 3 do we have. So in 2025 is the, you just need to plus 1, then divide by 2. You can find this is the 1013 odd number. Okay, so that means 1012 divided by 4 equals to 2, 5, 3. So we have 253 groups. So 253, we just times, because remainder 3, remainder 3, remainder 3, it will be 3 to the power of 253, then divide by 8. What is the remainder? Okay. 200, 3 to the power of 253 divided by 8. What is the remainder? It just list this remainder 3, remainder 1, remainder 3, remainder 1. So that means it's an odd number. 253 divided by 2 is remainder 1. So it will be remainder 3. Am I calculating right? Yes. Okay. Okay, so now the next one is I want to find the number which is the multiple of 125 and also divide by 8, remainder 3. So the next one you just check, right? 125 divided by 8, what's the remainder? And 250 and 375 and plus 125, which is 600. Is it 600? No, it's 500. Sorry. 500 and plus 125, 625, plus 125, 750, plus 125, it will be 875. And I think that's all. Okay. So which one divided by 8? We have a remainder 3. Which one divided by 8? We have a remainder 3. Any idea? Huh? Anyone? Are you still listening? Mm-hmm. Any idea? Hey, don't be careful about the time. Okay. 625, right? It'll be 625 divided by 8. 7 times 8 is 56. This one will be 75. And this is 9, remainder 3. So the answer is this one. That's all. 875. Is it 7 divided is remainder 3? Oh, yeah, this is also remainder 3. I mean, maybe I calculated wrong. I remember the answer is not this one. There must be some place I calculated wrong. Let me see. 15 times 7. Oh, sorry. 15 times 7 is not remainder 3. 15 times 7 is 105. 105 divided by 8 is remainder 5. I know. 105 divided by 8, what's the remainder? Remainder 1. So that means I just need to find out remainder 1. I'm stupid, sorry. This one, 1 times 3 times 5 times 7 equals to 15 times 7 equals to 105. So it should be 105. It's not 75. So sad. It's 105 divided by 8. All right. Divided by 8. It will be 1, 3, remainder 1. So it's always remainder 1, remainder 1, remainder 1. So the result is remainder 1. We don't need to care about anything else. So we need to find out divided by 8, which is remainder 1. Yeah. So stupid. Yeah, it should be like that. Sorry, I calculated wrong. Which one divided by 8 is remainder 1? Which one divided by 8 is remainder 1? $875, right? It's remainder 1. 625, right? So the answer is just the 625. I calculated wrong this one. 17 times 15 times 7 is 105. It's not 75. Sorry about that. Okay, so the answer is 625. That's all. Okay? So be careful about that. Sometimes the pattern you may find wrongly. Okay? Yes, very good. Okay? So I think here's today's things. And in a real paper, yeah, I can promise this several question, several knowledge points is quite important. Okay, some question, some kind of things will appear twice. Okay, so any more question you can just ask me. If no more, we just stop here. I know. Okay, no more question. We just stop here. Okay, see you next Tuesday. Bye bye.